He flew in last night from Seattle, and I had the pleasure of just having breakfast with him. And I think we're going to learn a lot about a company that is reinventing itself, or has reinvented itself in the last years. And Tim, I think, is going to give us a good view about how that reinvention efforts have come to a conclusion, and going to present the new way cloud with Microsoft.
Guten Morgen. Wie Chris sagte, willkommen bei CloudOps. Ich heiße Tim O'Brien und ich arbeite bei Microsoft in Redmond in den USA, wo ich arbeite auf Cloud-Strategie. Ich bin sehr erfreut, hier zu sein, aber mein Deutsch ist allerdings nicht fließend. So, wenn es okay ist, werde ich meine Präsentation auf Englisch fortsetzen. Is okay? So we're doing some testing here, and we'll get this thing worked. It's great to be here. I titled this talk "The Shape of Disruption" for a very specific reason. Disruption is a great word. Of all the words that have been used to describe what's happening in cloud computing, and I can advance it from here as well. Of all the words that have been used to describe what's happening in cloud computing over the last 5 years, I think disruption is probably the best one, the most telling. But it's also a loaded word. It's a word that packs a lot of meaning. People hear this word disruption and they make a lot of assumptions about what's going to happen with computing as we know it today. I think we all sort of understand that the progression of different eras of computing only come along once every 20 years or so. This is one of those eras. This is kind of a big deal. So what I'd like to do is just spend a few minutes talking about this idea of disruption in a historical context before we start talking about cloud and technologies and data centers. And where this really begins is I think, a historical example that resonates in the minds of a lot of people, which is the transportation industry. This is one of the examples that's brought up most often in the context of cloud computing. And this is the disruption pattern that you could call outright replacement. In the late 1800s, the horse and carriage was state-of-the-art in transportation, and there wasn't a lot to it. Somebody invented the wheel, they hooked up a horse to it, and that was as good as it got for probably a million years. And the disruptive technology that entered the space was the combustion engine. This particular photo is of the patent Motorwagen, developed by Carl Benz. If you've been to the German History Museum in Berlin and Unter den Linden, you can actually go see one of these. But as is not unusual, this was very, very expensive. This was a toy for very, very rich people. And along comes Henry Ford, who develops the idea of assembly lines and mass automation. It brings the cost down, and all of a sudden, this disruption is available to the masses, and the horse was replaced forever. And this is the disruption pattern that a lot of people think about with respect to cloud computing. There are other examples too, electrical utilities, all these other patterns in which the disruptive technology came along, replaced the existing technology, and the end state was one of outright replacement. But that's not the only pattern of disruption. There are others as well. This is actually an interesting one, the oven business. Ovens were, I think, progressed by the availability of gas and electricity, but the idea was pretty much the same for years and years. And one of the things that happened during World War II, during the course of atomic research, people figured out that you could use microwave radiation to heat food. This was the disruptive technology. This technology was licensed after the war to a number of different commercial providers who came up with this consumer product called the microwave. And in the early part of, or the middle part of the decade, the 1950s, this, like the patent Motorwagen, very, very expensive, very, very affordable, or not very affordable to many people at all. But the value proposition of this disruption was saving time in the kitchen for the subset of kitchen tasks for which this made sense. And this is where you start thinking about cloud computing. People said, hey, that's great, I'd love to save time. I'm all about saving time in the kitchen. Can I bake a cake with this technology? No. Can I reheat something that's left over? Yes. Can I broil a fish with this this new technology? No. Can I thaw out something that's frozen? Yes. And so once this partitioning took place between the things for which the existing technology continues to make sense and this new set of tasks for which this new disruptive technology saves time, that set the stage for this end state, which says every modern kitchen now has a combination of both. And the interesting thing about this, General Electric, which was one of the worldwide leaders in conventional ovens, and arguably the company that had the most to lose by this disruption, I think they're the worldwide leader, or one of the worldwide leaders in shipments of microwave ovens in these combination units. So we have this sort of hybrid state here, which is also a very, very common pattern of disruption. And the discussion today is what's going to happen to client server? What's going to happen to traditional IT as we know it because of this disruption called cloud computing? This actually is not stock photography. This is a photograph from one of our data centers in Chicago in the United States. And the big question is, what is the end state? Which disruptive pattern is this going to take? So for the next 20 minutes or so, we're going to explore this particular question. And in order to do that, let's take a step back and just talk about what exactly the cloud is. I think the industry at large, vendors like ourselves, the companies we compete with, analysts, industry pundits, we've all done a collectively bad job of explaining to the industry what exactly cloud computing is. So I'm just going to propose a definition here that is not my own, but I think a generally accepted one, which is it's really a design point. It's an architecture. It's an approach. It's a style of computing that involves a number of different attributes. The idea that finished services like apps, virtual machines, virtual networks, these sorts of capabilities are just easily provisioned on demand. The idea that resources like compute, storage, networking are pooled and used by a broad portfolio of applications. The idea that these infrastructures can rapidly scale to meet demand on an as-needed basis. The idea that these infrastructures, these apps, all this capability is easily measured and metered. So what we know today is that this design point is going to be implemented in one of three different ways. It's going to be implicated in a shared environment. A lot of people refer to these as public clouds. This is the business that we're in. Google, Amazon, companies we compete with, we're all in this business where we've taken this design point, we've implemented it in a shared environment, and then we just sell it to the public on a pay-as-you-go basis. Finished apps, infrastructure, platform. It's almost always off premises. It's almost always away from your data center. There's another implementation that says you can take this very same design point and implement it in a dedicated environment. Most of the time, that's within the confines of your data center. Sometimes it's in a partner data center, co-located. But it's essentially the same design point implemented in a dedicated fashion. And then we have these hybrid environments, which are a combination of the two. And the big question on everyone's mind is, what is the industry doing with these different implementation paths today? How is this playing out today? This is a set of results just from a very recent survey done. And the thing that we take away here, and if depending on the research that you look at or the analyst reports you look at, this may or may not be the right set of numbers. But I think the takeaway here is it's all over the map. There is no one clear winner. There is no one clear front runner. A lot of different businesses in a lot of different parts of the world, lots of different vertical industries are all choosing different deployment paths. So the question here is, why is this? Why isn't it just an obvious everything's going to the cloud versus an outright rejection of cloud computing into pure private cloud, modern data center, or just pure hybrid, which conventional wisdom would have you believe hybrid cloud is just going to be 100% everything. Well, I tried to figure out the right word to introduce this. Tension was the best word I could come up with, because that's really what we have here, a set of opposing forces at work against each other in pursuit of this end state. IDC did a study a couple years ago which asked the question, how are you feeling about what are your perceived benefits of cloud computing? It was one of these surveys that said, here are some benefits of cloud computing, and you should check the box that says strongly agree, agree, indifferent, so on and so forth. These were the top box answers. This conceivably is the reason you're all here today, this list of benefits. This survey was conducted against some 600 CIOs and senior IT leaders in multiple geographies, and there should be nothing surprising about this list. This is the value prop of the cloud. Pay for only what you use. I just get the features right away. I've taken capital expenditure and converted to operational expenditure. I've automated IT in all sorts of interesting ways. Now, this same survey asked that same set of recipients, here are some of the challenges associated with cloud computing, and this shouldn't be a very surprising list either. Security, reliability, the regulatory environment, certainly here in Europe, is one in which it's not inconceivable that some of these applications that go to the cloud are going to have to come back because a law changed somewhere, or there's some other business dynamic that forced that. And so that the tension between these two is really what's kind of put us in this situation of saying, I'm going to have public cloud for some, private cloud for others, and hybrid for both. So what I'd like to do is drill down a little bit into these opposing forces and just pick one of the things that I think is motivating public cloud, and then we'll talk about private cloud in a moment. And I think if you could really zero in on the one thing that's really driving adoption of public cloud, it's the economics. We get a lot of customers that come to Redmond and they want to talk about cloud computing. Many of them are deeply, deeply technical. They're very experienced in enterprise architecture. But at the end of the day, once you bring up the topic of economics, that's all they want to talk about, because there's, I think, a lot still to be understood about this particular aspect of the cloud. The thing driving economic advantage in cloud computing comes from two places: supply-side economics and demand-side economics. Supply-side economics is about data centers. It's about data center operations, its efficiencies. If you're building a data center, if you're building out infrastructure, that's the supply side. And the demand side is about how that infrastructure gets used. It's about the business units using the applications that run on the infrastructure. It's about usage patterns. It's about the fact that everyone fills out their expense reports on the last day of the month and puts stress on the expense reporting system, so you have these crazy spikes in load. So let's talk about these two independently. We did a study internally for Microsoft IT, and we've since published this externally. But we were trying to figure out what are the economies of scale that we could gain on the supply side, because Microsoft, as you know, has a fairly large infrastructure internally. We have over 1,000 applications. We have data centers all over the world. And so we did a comparison of the economies of scale in a 1,000 server data center compared to a 100,000 server data center, and found out that there are economies of scale to be gained in 4 primary places. Obviously, the server hardware, if you're buying in bulk, you're going to get a better deal. If you're buying more units, you're going to get a better unit price. Facilities and operations, this is really the labor that goes into looking after these applications and infrastructures in the data center. There are some tried and true metrics or ratios on how to look after a data center. You need 1 sysadmin for every 1,000 servers. You need 1 database admin for every terabyte of data, and so forth. And in a 100,000 server data center, even automating small pieces of this give you tremendous economies of scale. Hardware labor is really around break fix and facilities and operations. Combined with that, we're looking at real estate costs that are amortized over more units than a small server footprint, which relatively speaking would be 1,000. And then lastly, power. Power consumption is becoming one of the fastest growing pieces of total cost of ownership in the data center. It's the reason that Microsoft and our competitors as well, we build data centers close to cheap power sources. We build our data centers close to power sources in which we don't have to pay a lot of money for transmission costs to get it from one place to another. Turns out laws of physics cost money here. There's lots and lots of economies of scale to be gained on the power consumption front. So this is really kind of painting the picture on the supply side. So what does this mean? That means if you have this logarithmic scale on the bottom that says number of servers in a data center are going to range from 0 to 100,000 plus, and I've got this total cost of ownership figure in mind on a per server basis, it means a public cloud provider is going to see tremendous economies of scale when you get all the way out here to the right. And this is kind of a funny curve, because in public cloud, Google, Amazon, Microsoft, all of us who are playing in this space, we're not going to have a data center smaller than 100,000 units. There's no such thing as a public cloud with 1,000 servers. It's just a little ridiculous. So let's just put a point out here and say this is table stakes for being in the public cloud game. This is where ourselves and all of our competitors are sort of putting a stake in the ground, saying, if you're going to be a player in this market, this is where you have to start. We'll put a little tiny margin on top of that. This is not to scale. We're not marking things up 100%. And you wind up with this public cloud market price. And what this means is, if you're doing anything yourself, if you want to implement the cloud design point in your own data center, this is the price point you have to compete with. These are the economies of scale that you have to compete with. So if you want to implement a private cloud, you have this situation where you can get more economies of scale and be more efficient as you get more and more servers, but you'll never, ever get close to public cloud. It'll always be more expensive than public cloud. So if you're a small business, this is especially relevant to small businesses. I know there are a couple million of these here in Germany, the Mittelstand. These companies have a lot to gain by getting into public cloud. The cost advantage is huge because their economies are so bad in the data center. If you have a company with 50 employees and a couple servers, there are no economies of scale to be had there. Bigger companies have a lesser cost advantage, but it's still tremendous. So the takeaway here is that on the supply side, public cloud will always, always, always be more economical. It'll always be less expensive on a per server basis. So let's look at the demand side. And here's an interesting chart. These are some retailers in the United States. Some of them you may have heard from. Walmart, of course, I think everyone's heard of. Target is another retailer that competes with Walmart. Toys R Us is a toy retailer in the United States. And Barnes & Noble is a bookseller that competes with Amazon.com for online sales of books and music. And they all sell online. This particular chart shows the load on their web servers throughout the course of a given year, and not surprisingly, they care a lot about Christmas. The month of December puts a lot of stress on these systems. And so this is a kind of a very familiar thing for a lot of you who have seasonality in your data center. So let's just take one of these. Let's take the Walmart curve and say, okay, this is the server demand that I have to deal with for this workload in a given year. And I want to implement a private cloud to deal with this problem. One of the big secrets of private cloud is you still have to provision the infrastructure to meet that demand. Just because you've done a great job automating service management, just because you've done a great job implementing the cloud design point in a dedicated environment, doesn't mean you still get to blow it at Christmas. You have to have enough infrastructure to meet that demand. So what if I take this same curve and say, okay, I'm going to push this out into a public cloud. What are the resources that I need to spend money on to meet this demand? And it's a very, very different picture. This is what it means to pay for only what you use. And so the difference between these two yellow curves, the area between them represents the cost savings in terms of resource provisioning. It represents the fact that you have a big capital expenditure here to build out the data center capacity for the private cloud, whereas on the other side, you basically have an operating expense that says, I need to spin up a lot more virtual machines during the month of December, and then when January comes around, I can turn them off and business returns to normal. So what we have here is a situation where the economic case for public cloud is pretty solid, and I'm being deliberate in my words. Economically speaking, public cloud will always, always be superior. Unfortunately, the world cares about more than just cost savings and money and economics. So let's go back to some of the tension that we talked about earlier in terms of the concerns associated with cloud computing. Barriers to adoption. These are some easy ones. There was some research done a couple years ago that was repeated a month ago, where a set of CIOs in the UK and the United States were asked about security, reliability, and their perception of return on investment. Turns out there's still a lot of skepticism about whether or not these cost savings are real. Security is an interesting one because that's the number one, obviously, barrier that we get asked about. And I think the emergence of cloud computing, the emergence of these large services on the web, the dependence of businesses on the web to do interaction with their customers. See, there's like the electronic payment, electronic banking type scenarios have created a lot of nervousness around bad guys breaking into infrastructure and stealing credit card numbers and things like that. Reliability is another one. If the biggest company in the world had an email system that went out today, the only people who would know about it are the employees of that company and the users of that system. None of us would hear a word about it. If a public cloud provider had an outage, it would be on Twitter within minutes. There'd be articles written about it. There'd be a lot of attention given to that particular outage, that particular service interruption. And so it creates these perceptions that I think have driven a very, very peculiar phenomenon, where in 2009, the question was asked, how do you feel about security, reliability, and cost savings? And they all said, 27% said, I'm very nervous about security, and 29% said, this reliability, I'm just not sold. And you go back 3 years later, and you figure 3 years of market education would make people feel better about the cloud. The opposite happened. They actually are more freaked out about it because the more they find out, the more nervous they get. I think there's a lot of perception associated with big, high-profile outages that attract a lot of attention, whereas those of us who've worked in IT for years and years, which I'm sure all of you have, know that unscheduled downtime is just a fact of business computing. It's not particularly unusual. And then the perception of cost savings, there's still a lot of skepticism there. So there's some particular characteristics of the European market as well. I don't think I need to spend a lot of time on this point. When you start looking at Germany and Europe in particular, there's a lot of, I think, particulars about this market that are also creating barriers to adoption as well. So you have the economic case on one side, which is very strong. You have some of these barriers to adoption that are very, very real. So how do we think this is going to play out? The tension between these two is going to result in something, I think, that looks like this. I've labeled these axes public cloud economics. This is the economic advantage you would get from adopting a public cloud approach. And on the horizontal axis, private cloud preference, which is essentially public cloud reluctance. They mean the same thing. And this tends to vary by the size of the company. So take the Mittelstand, the small, medium-sized business. There are 30 million servers in the world. It turns out that the vast majority of them are in these companies that have not that many employees. This is the largest subsegment of server deployments in the world. It's in these types of companies. These companies never ask us about private cloud. They want nothing to do with server infrastructures. They want nothing to do with data centers. They want to run their businesses online and just have mobile devices. And that's how they operate. You get into mid-sized companies. Now we're getting a little bit of economies of scale here. We're also getting into bigger companies that are worried about the regulatory environment, bigger companies that are more worried about privacy and security. Start getting into enterprise companies. They get even bigger. The pyramid gets a little narrower. There's not that many companies compared to the small to medium size, but you kind of see where this is going. Government is an interesting one. It's very, very fragmented in most countries. That's certainly the case in the United States. I would imagine it's similar here in Germany, where these companies have a these governments have a strong preference for private cloud. But because they're so fragmented, they look a lot like small businesses on paper in terms of the economics that they have. If they became consolidated, they would be as big as some of the biggest public clouds in the world. So this is a market segmentation. What's interesting, though, is what happens if you just take a company, a typical company within this taxonomy, and say, what's happening under the covers here? It turns out that these companies all have a portfolio of capabilities. Not all applications are created equal. Not all workloads are created equal. Not all workloads have the same number of servers or the same number of investment associated with them. So what would happen if we partition this portfolio out to these different applications and workloads, and you have a picture that would look a lot like this. Some of the workloads that you see in the upper left are just sort of easy ones for cloud. Web, collaboration, email, development and test, spinning up VMs to build a test harness in a hurry. No more calling IT and begging for a server for 2 months. CRM is a very mature category for line of business. But then you look over to the lower right, and you see things like custom business applications, security tools, ERP, mission criticality. And so what we think is going to happen over time, we think this partitioning, I think, represents the reality of where the market is today. And then these applications and workloads will increasingly move to the upper left. And so the question is, how do we do this partitioning today? I don't know the answer to that. I can tell you how Microsoft IT does it. We have an approach that we use that basically subdivides all these parameters into a set of business factors and a set of technical factors, and then on an application by application basis, we make a decision. Are we going to move this thing to the cloud now? Are we going to think about it and gather more information, or are we just going to sit on it and do it later? So there's a set of business factors here. What's the economic opportunity? What's the mission criticality associated with this? Is this a regulated application, regulated workload? What's the regulatory environment around this? And then a set of technical factors. How hard is it to do this? If we move this application to the cloud, is it going to run cross premises? Because that's harder to do than having it run one place or another. How hard is it to look after this from a management and monitoring standpoint? How hard is it to do the integration? So this is just a thumbnail view into a pretty sophisticated process that we use, but a lot of the companies that we talk to take a similar approach to doing that partitioning as well. So the one thing I'd like to leave you with, and I promised Chris I would end on time, is we return to this taxonomy. If all the companies in the world, no matter how large or how small, are going to choose some version of these deployment paths, the thing that we've talked about most over the last 20 minutes or so is just apps and workloads. But it's actually much more sophisticated than that. So as you start to think about cloud computing and how you're going to adopt it, you should not only think about applications in terms of spanning all three of these different deployment paths, you should think about an application platform that spans them as two. So if you write an application once, can you deploy it to a public and private cloud? You should think about development tools that have the ability to span multiple deployment paths. You should think about a virtualization platform that can give you the ability to put an application package in two places without having compatibility challenges between the two. One virtualization platform that runs everywhere. Identity is something we could do an hour on just on that topic alone. Having one identity system to really enable single sign-on for applications that run in multiple places is an important thing, because if you have a separate identity and an auth system for each and every service endpoint that's running in these increasingly complicated clouds, you can imagine how bad the user experience is. You can imagine the complexity on the IT side. And then lastly, management, having a single pane of glass where you can look after all these things. So in terms of pragmatic advice, when you're talking to vendors, here's a decent list of questions that you should ask them about how they're going to enable these categories of capability across public, private, and hybrid. So with that, we're out of time, but I'm going to be here all day. If you have any questions or want to discuss any of this offline, I'm happy to chat and meet with several of you. Thank you very much.